your questions. We're joined today by our speaker, Frank Kadwell, Dr. Frank Kadwell, I should say, who is going to be telling us how we can get the squeeze on Python. But before we leap into that, I've just got to thank our sponsor, InfoSec, whose contribution allows us to run these streams every month and to bring you these fantastic speakers. Now, Frank is a PhD in data management specialist with over 20 years of experience in the IT industry, and is the co-founder of D3 Information Services, a boutique consulting firm in the US, and which assists companies with many data management challenges, including strategy, architecture, and development. And Frank is here today to talk to us about Python. Python, one of the most ubiquitous languages used in analytics, but also throughout IT. Frank wants to tell us about what Python is, why it's so popular, and where the industry may go from this point forward. Those are the details that I got from your description, but Frank, I'm very interested to hear what you have to say about it. So I'm going to pass it over to you. Thank you so much for joining.
Thank you. Yes, absolutely. Thank you for having me. Hopefully you can see my screen now, or the slide.
I can.
Great. Yep. Thank you. Thanks for that wonderful introduction, and welcome everybody that's online. So I'm just going to jump right into it, and we're going to talk about Python, and I'll first just go through an agenda, and then we'll kind of jump right into it. So one of the, just to kind of level set everything, we'll talk about what is Python and the highlights of the Python language. We'll talk at a high level in terms of features and things that people may or may not like, what the vendor support is like, kind of why it is where it is, and how it got positioned as well. That'll kind of segue into why is Python so highly used in the environment, especially within ML and AI. Excuse me. There's other languages, obviously, that are highly used in other areas, but when you talk to data scientists, Python by far is probably the highest used language on the market. So we'll specifically get into Python and analytics, talk about how some of the things that can be done with analytics, some of the tools that natively use Python, all of those details. And then we'll talk about some of the basic things like just an IDE. So there's specific Python development environments, as well as many environments supporting Python. So we won't get too deep into those environments. We all know Visual Studio, we all know Eclipse. Those environments do offer Python plugins, but there's also a very specific Python IDE that's put out by JetBrains. It has like a lot of tools, it has a community version and a version that you can purchase. And again, that's a very user-friendly environment. We'll use that as an example, and that's a pretty feature-rich environment. We'll talk about the Python libraries. We'll actually hit on the Python libraries in two areas. One is in the Python and analytics, but then we'll kind of talk about the libraries a little bit and just the sheer volume of libraries that is out there. This presentation won't even scratch the surface with the libraries. So, we'll just talk about it again at a pretty high level. And then we'll also talk about other products that are alternatives to Python. So there are some products out there that I don't want to say compete, because Python is open source and you can just go download it. That's probably one of the reasons why it's used so much, and we'll get into that. But there's other software out there, either paid or otherwise, that could be used to achieve a lot of the same goals. And just to give you some background on myself, I actually do teach as well as consult. And one of the classes that I teach is at Southern New Hampshire University, and just to give an idea of the ubiquitousness, if that's a word, of Python, they literally have almost all of the programs have an introduction to scripting class, and it is Python that is used. So I actually teach that intro class every term. They have 8-week terms at Southern New Hampshire University. And we actually go through pretty quickly, especially for people that are brand new to coding, sort of the goings on within Python, and just get used to how it works and all those sorts of things. And just for some fun trivia, because I was curious as well a while back on where the name Python comes from. I've always thought, at the time I was thinking, oh, maybe it's the snake. Well, I don't think it is, because I guess rumor has it that the person who first developed this language was a huge was watching a lot of Monty Python's Flying Circus. And so he wanted a catchy name and something short. So he called it Python after Monty Python's Flying Circus. So there's your useless trivia for the day. And we'll get on with the first item on the agenda. So the Python language in general. First off, it's an interpreted language, and it's not compiled. So when we talk about that, what do we mean by interpreted language? Interpreted language means that there is no compilation, literally. And so the computer looks at the language, it never puts it into any kind of executable or binary format through a compilation, and it just goes through the script. So you can think of Python similar to PowerShell scripting if you're in Windows, or Bash scripting if you're in Unix, or those people that know PHP or things like that. It's very similar in the way it works with that, in the sense that it's not compiled. Now, there is something called bytecode, which is essentially a virtual machine that will make the code run faster. So because it's not compiled, the code doesn't necessarily run quite as, well, it doesn't run as fast, period, as something like C or C++ or those types of compiled languages. It's not quite as big a deal anymore, that now that we have computers that are very fast, so it's generally not a huge deal, but in some cases it is, and you get a lot more control with things like C and multi-threading and all those sorts of things that isn't necessarily readily an option in Python. But you do have sort of this middle ground of bytecode, where it's a virtual machine that's kind of this Python machine, and that will run a little bit faster, but it still won't run quite as fast as compiled code will run. However, and we'll get into this a little bit more later too, probably, but the compilation piece, while it can be faster performance, it's not as platform independent. So Python, because, and other languages like it, Python's not the only one, PHP and all the rest of it, they're very platform independent because they are interpreted. So you don't, because if you compile something, then it's built for a specific platform that the executable can understand. I mean, for example, if you compile a C program for Windows, you probably have to compile a different one for Unix and all those sorts of things. So they're very platform dependent in that case. Python is a high level and easy to understand language. And we'll look at some of the lines of code, and people that do coding are going to look at it and be bored to death, and that's fine, because it's very readable. And so what that means is that data scientists can be paid more for being data scientists, not working in, not trying to figure out how to write a language or program and those sorts of things. So it's a little bit of a nicer language for novices. Having said that, it is dynamically typed, which again, initially is easier for novices, but we'll talk about some of the downside of dynamically typed languages as well. And what dynamically typed means is that you don't have to set a variable type and it doesn't instantiate into that forever. So you can literally be shifting types with variables all over the place. You just set it equal to something and it makes its best guess as far as what type that variable is. And we'll look at some examples of that. Obviously, the upside of that is that it's easier to run code. The downside of that is it can be a lot harder to maintain that code. Garbage is collected for those people that do C in Python. So you don't have to worry about deallocating variables and those sorts of things like you do in C. As we, well, at least I'm old anyway. Back in the day, it was always said that Java was basically C with garbage collection. So it is kind of keeping track of the memory space. Obviously, that can be less of a big deal in today's world sometimes, but it is nice to know that it's there. So to kind of dig a little bit deeper into the dynamically typed and what is meant by that is that what it does is, and you can see it in the slide here, is you set a variable called state_prev, and that equals an empty string. So in this case, that's going to be an empty string, and it's going to assign that variable to be a string. I didn't actually tell it that. Like if I write something in Pascal, for example, that's a very TypeScript language, and I have to declare that variable before I can use it as a string. Likewise, with the rate variable, that's a float because it has a decimal on it, and so on and so forth. The counter is an integer because I just set that to 1. And then this is an example. The last one is an example of using a library, which we'll get into. This is pandas is probably one of the most common sort of data querying library and such out there, creating data frames and those sorts of things. And so this is getting set to be a data frame because that's what I called it. I didn't declare it anywhere else. I can then set this variable equal to something else, and all of a sudden that's going to reset what type it is. So it's nice in the sense that you don't need to predefine a variable, but the flip side of that is it makes debugging and maintenance much more of a headache. So you need to be a little bit careful when you're using variables and make sure that you keep track of them. So within Python, formatting is everything, and it will actually give you errors if you do not indent. So the way the interpreter actually works is, so if I'm in C or something, and obviously it's not a good idea to do that, but I can go through the code and I cannot have anything indented, and it doesn't care as long as I have semicolons where they're supposed to be and all the rest of it. I could literally put everything on the same line. Python does not work that way. It does have a colon for specialized things like if statements and stuff that's basically saying it's going to, there's continuation. But when I do this if statement, the next thing has to be indented so that I'm within that if statement. If I have this if statement out here, it's going to flag an error, and so on and so forth. And I can, obviously I have, a lot of nested ifs in this, et cetera. And so you need to be really careful with the formatting. Also, it uses a lot of conventions that those people used to Java or C or those types of things will recognize, like the double equal sign. That's a test to see if it's equal. The one equal sign is an assignment, so it's not testing if things are equal. And then you have greater than and less than and all that fun, as you can kind of see throughout this data. And like any other language, you can set things, but you can then see that this is very, readable. It uses a lot of, common language, at least in English. And so you can see where it'd be a pretty easy language to learn, all things being equal. So why is Python been so highly used? Why, what are some of the reasons for it? First and foremost, I think one of the things is it's open source and it's so easily available. So if a person wants to put functionality into their software, and we'll talk about some different pieces of software that use Python basically as its language, you can put it in there and there's nothing wrong with it because it's under the GNU license. So it's open source. Open source also has become more accepted. So I think there was a lot of questions out there for a long time of, is open source, what are you going to get from the indemnification and all those sorts of things. And what people have found out is that vendors have really, I think, under-delivered, quite honestly, on those types of things that they view as advantages to open source. And as a result, many businesses have started to move away from sometimes vendors because they feel sort of like they're in vendor jail, so to speak. The other thing about Python, again, because of it being open source, then, I mean, just from a sheer practicality standpoint, you wind up having a lot of resources available. Because what are we teaching in the colleges? Well, we're teaching, when we teach a scripting class, we're teaching Python. We're not necessarily going to teach PowerShell because I don't know what type of operating system a person has on their machine if I'm teaching a class or those sorts of things. I mean, you can, and there's PowerShell classes, but I'm just kind of using that as an example, I guess. Python winds up being a very logical step for scripting. And then the next thing is the availability of libraries. And I added to this killer app. So people, and I don't mean to bash Microsoft, but people did not go to Windows back in the day because they loved using Windows, right? People complained about Windows 3.1 probably more than any OS I could ever imagine. But what did they have? They had applications that were built for that OS. So people put up with the problems of Windows compared to, say, at the time, I'm dating myself now, it's back in the 90s or whatever. Unlike, say, Apple or something, which kind of had done a bit of a detour at the time, and they didn't really have a lot, and they didn't offer Office products and all those things. And what was the killer app? The killer app for business was the spreadsheet. And so Python likewise has the killer apps. They have written within the various AI and ML tools, Python is right in it. So people then start to use Python, and they start to use Python for other things. So, OS2, it used to be said that OS2, I mean, funny story, people used to comment how OS2 ran Windows apps better than Windows did. Well, nobody cared because they weren't going to install it because they had Windows, and it was because of the applications. So that's another piece. As we kind of looked at the language quickly, it's easy to learn, and it's a lot more readable. So, obviously it's a little bit hard, on the intro side for people that have never coded. That's sort of a big jump, but for someone that has coded, they're going to be able to learn Python really fast. They don't need to worry about resetting things or doing all kinds of different somersaults just to get something written out to the screen. Another huge one is the platform independent side. So because it's an interpreted language, because it's a scripting language, you can use it on any platform you want, as long as you have, the Python interpreter installed. And you can literally just go out to Python, download Python if you want, create, a Python script in Notepad and run it. So they just started to do it that way. It has an IDE, which is nice, and that's an integrated development environment. Excuse me, should have notated that in the slide. And again, that's easily available. You can download it for free. SNHU wants me to use it in my class, so I do. I'll say that I don't get a lot of worthless email from them, so it's easy to just download the community version and not be bothered if that's what you want, which oftentimes we do. And so that's another feature of it. And then also you can easily have an environment that includes Python, but Python is not the only language that's used. And so you can easily offshoot to other things. You can create scripts. An example of that, and we'll talk about it in more detail, is say like our statistical modeling tool. You can actually use that tool and you can call Python scripts or use Python within all of those sorts of things. So it winds up being very flexible, easy to use, and people just gravitated towards it, partly because vendors have not been always very easy to work with necessarily. And then it's also highly used in research. So obviously, getting my PhD, I had to go through, the gauntlet of research, and I still do research. And one of the things that's required in research when you create a paper is you have to provide the data, and you have to provide basically the recipe of how you got to your answer. So then people can replicate that research. Well, people do it a lot in Python because, again, it's not costing, somebody doesn't have to go out and buy a tool. Again, we'll talk about in a more detail. Probably the next biggest one that's used a lot for data sets is MATLAB, and that has a price component to it that Python doesn't have. Now, you don't have to write as much code in MATLAB, so I'll say that much. But again, so there's some trade-offs there, but for a lot of, it's easily available, and so a lot of people use it in a lot of the various research that's done. So let's talk a little bit about Python and analytics. One of the biggest packages and libraries that are out there that just has endless querying, merging, sorting, all those sorts of things, capabilities. You can connect it to databases, or you can connect it to flat files and all those sorts of things, is pandas. And so you literally just put at the top, you easily download the pandas library. You just import it into your code and you're done, and you can just use it. It's really easy. Again, there's not really any installation because it's just interpreted on the go. So it has data structures in it. Again, you can do merging, sorting, all different kinds of queries. It's excuse me. It's very it's sort of the, if you will, you can do joins with flat files, all those sorts of things, and data frames and data sets, so that it really makes it easy to just get things going. And then it makes it easier to gather data from external sources, because you can get stuff from flat files out on the internet. You can, whatever you need, you can run it and use it. Other ones that are real important are things like Keras. So Keras is a deep learning tool. It's probably between that and TensorFlow, it's probably one of the highest used tools out there. And Python is built right in it. It uses Python, and you write Python code and then the Keras engine runs it, and you can do fast prototyping. And the big one with Keras and TensorFlow as well, for that matter, is you can actually then access your GPU. So as we all know, GPUs are becoming, they're a huge deal within the AI and ML world. I mean, you can put a little GPU on your, excuse me, on your home system, and you can literally, make things run orders of magnitude faster, because you have the GPU doing things that CPUs just, completely get stuck on for literally hours or days or whatever. And also, these things are usually on-prem. So I guess I'll just be blunt, is that if you try to do cloud and you're doing GPU stuff, you're going to watch that cost ticker really go up in a hurry. It's quite honestly cost prohibitive in many cases. That's why there's so many like AI, literally AI hardware boxes that they just build, like you build out a PC or something, and people put it with, on-prem, because it's just so expensive to be running GPU cycles on the cloud. CPU and compute is, a lot more competitive, but if you try to just there'll be things that can't be done in the AI world, as we all know, on a CPU, and you pretty much have to have a GPU. And Keras, again, is open source, so it's free. So, or it's under the GPL license. So it has a whole scikit learn. These are various ML algorithms that are already built in the tool, like clustering, just basic algorithms. It does a lot more complicated ones as well. Linear and logistic regressions, regression classification, all those sorts of things that we doing ML all the time. And it's a library, it's right there. There's no need then to write all new code in order to run your system. So you don't need to, excuse me. So when you have a project, you can quickly get work done because you already have these libraries built. A lot of the other languages, in a lot of cases, don't have these types of things straight out of the box. You wind up having to program. The next one, which we kind of touched on, is TensorFlow. This is good for setting up neural networks, training the neural networks, and basically working with massive data sets. With TensorFlow, again, that's one that is basically, it's a Google supported open source project. TensorFlow can be both run in the client. It also can be run in the cloud if you want to. Again, that's something that you just need to be careful of, because you can really watch your cloud spend go up in a hurry doing AI and ML stuff. I'm sure that a lot of people on this call have had a lot of experience with that already. So that's always something to be careful of. So just kind of hitting on and discussing, the Python development environment in general. So just to kind of introduce this subject a little bit, you don't need to have a development environment if you don't want. So if you're just trying it out, you can literally open up Notepad if you're Windows, open up Emacs or VI if you're in Unix, you can install Python. As long as you have stuff indented properly, you can start running scripts and you can start doing stuff with it. Of course, that gets to be a bit of a challenge in a hurry because it's not as robust an environment. It can be hard to see errors, all those sorts of things within that type of an environment. So you need to be a little bit careful in what you're doing, and it can be a little bit harder to debug things. So the one thing about Python development environments is it's very flexible, like everybody supports them. So as we know, Microsoft eventually got smart with Visual Studio, and now they offer, the free version of Visual Studio because it's sort of counterproductive to not to, and they want people to develop with their stuff. So if you want to do that, you need to make it available. And so you can easily, if you're in a shop that uses Visual Studio, which is probably what's mostly used out there in the marketplace, you can easily just download the Python add-in, and it'll put all the context sensitivity you want, all those sorts of things, so that you can much more easily edit your stuff. Another one is Eclipse. Eclipse has plugins as well for Python. The other thing that they have is sort of, I just call it its own one, and it's called PyCharm. PyCharm is put out again by JetBrains. That I'm using PyCharm in the examples that I'm showing in the screenshots. And it's again, it's a very friendly environment. It plugs into a lot of stuff. We'll kind of cover it in more detail later in later slides. But it's and it's very easy to install, and you can have, you install Python, or you tell where Python is. So I mean, basically installing Python is just unzipping the file when you go out to Python, and then you just point it to whichever one you're using. And so, if you're using Python 3.9, you just point it over to that directory. And of course, there's a standard directory setup, and then it just uses that, and it interprets through those types of that code set that you're using. PyCharm or Python, it definitely has made a lot of upgrades. I mean, I would highly recommend using, like the high 3 versions. The 2 versions can get a little flaky on some weird stuff, might drive you a little crazy. So just be aware of that. And so why do we use an IDE or a development environment? Again, it's a little bit of a bigger footprint. You got to install a piece of software. But generally, when we're doing larger projects, especially, it becomes a requirement. So if we're writing a lot of code, or even, I mean, it doesn't even take that much for me anymore, I'll admit, because, I don't know, I think my brain shrinks by the minute or something, but it's just one of those things that it just makes it easier to track things. It has a lot of them come with debuggers, obviously, so you can step through things. And we'll get into some of those details, in the following slides. And so I would just say pick your favorite development environment if you have one, and it'll probably support Python. So of course, this is for those people that maybe don't have a lot of experience with IDEs. We'll just kind of go through some of the highlights, I guess, of having a development environment, and they're all kind of, for those people that have used a development environment, this will be review. But you've got, the biggest thing is you've got colors. And so you start to, this is orange. So that's a keyword. And then, you're importing, and then this is the library. And because it's in sort of this cream color, that you found it. If it doesn't find this, it'll give a squiggly line under it that says, yeah, I don't know what you're talking about here. And it'll do it right away. It'll be a red squiggly line, not like the green one down here. Then you've got, this means that there's a variable set. You got the different colors here. You open up your parentheses. And then as soon as you start up your quotations, then it goes green, meaning that the string goes on. If I kept going past the plans.csv and didn't put a close quote, that green would just keep going on and on and on until I put the close quote. So when I'm looking at the code, I can easily figure out, oh, I didn't close this quote. And then the red is a special thing that it sees in the library, and you can use that, and so on and so forth. That's a parameter that you're sending into the system, and so on. And so you can see where it just becomes a lot easier to do things. Your comments are kind of this brown color that it has throughout. There's a pound sign on the left of this. It can't be seen because it's the minus and the pluses, but it sections out your code. And then also over on the left, there's line numbers. I apologize, they didn't come through in the screen print. They might in the next one. So I couldn't get this all on one slide, so I did it like in 2 sections. So over here on the right are these line numbers. Over here would be the code. And then here you've got all your projects that you have. Just like if you use Visual Studio, it all is kind of the same pattern, right? And then what you have is you have within your, it tells you where you're looking at this given project. So this is, just a generic Python project that I have. I copy and paste code in out of it all the time. These are the external libraries. This is telling you where it's looking for the version of Python that it's using. And you can actually put the external libraries, make sure it can see them in here, all those fun things. And you can use, you can install the external libraries and stuff like that as well, and make sure that things can be seen by all of your programs. And then the next one, I just wanted to kind of highlight sort of some of the functionality, right? So one of the things that plugs right into Python is Git. We all use Git. You can actually have it log into GitHub if you want. You can connect it to your own Git environment if you have that. And so you can version your code using Git, and it's all right in PyCharm itself. Just like Visual Studio, you can do that, just like Eclipse. So it has all of the important elements that you need in order to do real sort of, well, I shouldn't say real, but more complex code development that has a lot of moving parts, that has multiple developers, where you need to version code. All those sorts of things are within that environment. So that's the development environment. And then we get into libraries. So there are just countless libraries in Python out there. It's probably one of the big reasons that it's so popular. Is that, if you need to do something, there's probably a library out there that will give you a really good start on it. And so that's one of the things that makes Python so popular. Another thing is it's included in so much software. So you have Keras, you have TensorFlow. We'll talk about it in the next one as sort of one of the alternatives to Python, but R. You can literally write, you can connect R to Python and you can use them interchangeably. So you don't always have to write R code if you don't want to write R code. If you're a person that knows Python and you want to use Python, but you want to use that in the R environment, you can do that. Another big piece of it is there's a lot of Python specialized libraries that people have done a lot of writing about. So for example, there's a whole natural language set of libraries in Python. There's literally books written about it. So you can actually walk through it. You can do research based on it. You can look at how it's working, all of those things. And then people can just customize their own libraries and create their own libraries within their own development environment. The other thing too is that you're just going to find a lot more easily found support for Python in a lot of different areas. So for example, there's, as we move into AI and ML, there's certain things that I think that we need to think about as we move. We can't just blindly be doing AI and ML. There's cost to doing it. There's, issues that are out there that are beyond, there's sort of ethical issues that go along with it. Sort of, there's things like one of the things that got caught onto, and then you can easily download these data sets is, a person did a paper recently, or maybe a year or two ago, that basically stopped Amazon and their facial recognition in their tracks. Why? Because it was basically favoring the white race over people of color. And so those are the things that we need to think about. And by using something like Python, people are commonly then using alternate data sets to help, level that playing field. If people ever want to read about stuff like that, there's a really interesting book out there called Weapons of Math, M-A-T-H, Destruction, which is very interesting, and it discusses it's US centric. So, but I'm sure Canadians know all about the US issues down here, but it talks about things like mass incarceration and schooling and all those sorts of things, and how we need to even those playing fields. And so it's helpful to keep these larger entities at bay, things like the big 5 or 8 or whatever they call it, IBM, Microsoft, Google, Apple. Those are the big AI companies that are out there. The rest of us don't have access to data like they do. Facebook, obviously, as well. Those types of large tech companies. But so it's all interesting. And so as we do this type of work, I think it's important that we keep a check on each other. And that's one of the advantages of using a tool like Python, because it's open source. We can all answer to each other, which I think is important as a community. So just kind of looking at some alternatives to Python, I kind of hit on one of them quickly, which is MATLAB. That's sort of a specialized ML and AI tool. If you look at research, that's probably going to be the other big one that people use a lot. And MATLAB's great. I've used it. It's nice. But again, I think they have a version out there that you can use that is not, as long as you don't use it for commercial things, but I'm not sure. It is, if you use it, you can get like academic licenses and stuff for it too, which are a little bit cheaper. So it's not totally cost prohibitive. The one nice thing about MATLAB just, is that with Python, you're actually writing more code. MATLAB, you don't need to be right there writing as much code. But I think most people that are doing this kind of research, learning Python is really not that much of a hurdle. If you're doing ML and AI in the first place, yeah, it's just not. I mean, you're probably have some experience at least with statistical tools, so making the jump to Python is not necessarily as big a deal. Which kind of brings me to the next one, and that is the R statistical tool. So that's another alternative. You can write things straight in R. R is, I used it in my thesis. I use it in a lot of other things. You can use Python within R, so you can actually mix those things together. R has really taken over again because it offers the same or better functionality than its counterparts of SPSS and SAS and those sorts of things. And again, it's open source, so you can download it, you can participate in it, you can talk to people about it. R is a little bit of it has a little bit of a different spin on the open source side, in the sense that, which actually I think personally makes it better, because in the statistical world, you want to make sure that you're using the algorithms properly, that you're using proper statistical models and those sorts of things. So there is a committee that is used of statisticians. Sorry, I can't say that very well, that look at code changes and things like that, and make sure that it doesn't have any, that it's not wrong, quite frankly, or the algorithm's wrong or something like that. So there is a little bit more more rigor around getting stuff into the tool. But again, other than that, it subscribes to all of the open source qualities and that sort of thing. And to me, that makes it better, because it's become very acceptable to use it in research. For example, oftentimes when we do research projects, we actually have to get it through some sort of board. For example, when I did my thesis, I had to get it through an institutional review board. And if something wasn't properly vetted like R, then I wouldn't have been able to use it. So in my case, I was able to use it, and I was quite happy using it. On the rest of them, I mean, you're kind of in the languages, and most of them are probably pretty obvious, Java being one of them. Obviously, that's a compiled language, so it's got a lot of differences to Python, but you can do a lot of the same things in it. It's just that it's not going to be quite as hyper focused on the AI and the ML world, because people are probably spending more of their time doing those sorts of things in Python. Likewise, Perl again is another, it's going to be more of a scripting language along with PHP. Those two again, PHP is of course, very much used in the web world and content management tools like Joomla and WordPress and all those sorts of things. Perl, unfortunately, I mean, it's a great language, has a lot of neat stuff to it, but it just sort of, I don't know that people use it that much anymore, that I've seen anyway, at least out in the marketplace. But there is scripting that's done in it, and there's plenty. I mean, there's probably more to mention. These are just sort of the highlights that I've hit. But those are the different tools that are out there that, quasi, I guess, are alternatives to Python. I would say the big alternatives are things like MATLAB and R and SPSS and SAS and that sort of thing. The other languages, Python, I think, serves a different need. If I'm going to go out and I need to do, I mean, I'm not going to use Python if I have something where I'm really trying to, multi-thread something, and it's, and high performance is absolutely needed and all those sorts of things. But generally speaking, when you're doing an ML and an AI project, that's not what your main goal is. Your main goal is distilling down this data into something that's usable, into some sort of predictive model, all those sorts of things, which, Python has a zillion libraries to do that in. So again, it gets to kind of the right tool for the right job, and you're going to do multiple things to do it. So that ends my presentation on Python. I really appreciate everybody listening. Are there any questions out there, Nick, or did I successfully put everybody to sleep? Or
it was a fascinating conversation, and I actually do have a question.
Sure.
A couple different times you mentioned how strength of Python was its open source nature, which I absolutely understand, because you're right, everyone can add to it, and it allows just freedom of all these different groups of people to take part. So I'm curious about your thoughts on a recent event that happened that in regards to some open source projects. I know one of them was called, I believe, Faker.js, where the creator of Faker.js got very upset with corporations using his code. And so updated it a couple times with junk data and just destroyed it. All these corporations had it automatically updating the dependencies on updates, and it actually knocked out a large amount of websites. It has affected just as much regular users, independent, nonprofit people using it, but hit the corporations as well. And his screed was about the corporations taking advantage of nonprofit, of open source type stuff. So I'm curious if you see this as a flaw in open source, or if this is corporations accurately taking advantage of these kind of systems, or what's your thoughts?
Yeah, I mean, the thing that you do have to be careful of with open source, and I think you bring up a real, it needs to be truly community driven. So you need to look at how the project is run. So in other words, there's a reason why Apache has been around as long as it has, right? And all of the different things, all the different offshoots of Apache, including, quite frankly, things that we use in ML and AI, like, Hadoop and all the rest of it. Spark, that's Apache, at least Hadoop isn't, I'm sorry, but Spark is, and all those sorts of things. And so, I mean, that's the one advantage. I mean, look, I'm not a Google lover or hater, or Microsoft lover or hater, or anything like that. But it is the one advantage, for example, of TensorFlow, right? Is that there is some kind of governance factor in there that's making sure that somebody doesn't go, that doesn't sort of put their own personal agenda in there. But by the same token, and I don't know much about the specifics of what you're talking about. I apologize for that, but
no worries. I heard about it because I do web dev.
I have my zones of where I'm just not ignoring the news because I can't deal with it. But I think that having said that, I think that it's a good idea, especially for larger corporations, to be good stewards of these open source communities. So if you like something, and especially these larger corporations, you can have somebody, and they don't need a lot of help, 5 hours a week to help with testing or something, and be a part of that community and have a stake in that. I'm probably a bit Pollyanna, I'll admit it. I'm kind of a community oriented person. I think we achieve a lot more as sort of a whole, which I think is the goal of open source. Yeah, I think there's always going to be kind of these isolated circumstances. I think what you describe is exactly, one of the best reasons that R does it the way that they do it, and they still fit into the GNU license. So they literally, I mean, you cannot just put a piece of code in there. You can't. It's not going to happen. And so I think you have to look at sort of the open source governance structure. If you're going out there and it's one person that's sort of gonna, run rampant with it, then you're taking a bigger risk.
Does that help? Absolutely. And I think it emphasizes the fact that I don't know if it's as big of an issue on Python, but that when your project does have dependencies on projects, it's good to understand those dependencies, even just a little bit.
Yeah, it absolutely is. And look, everything has its, its flip side, because, one of the conversations we've got, I mean, I mean, to be quite honest, it's somewhat vendors' fault as to why people started looking to open source, because vendors, are not understanding. Like let's use Microsoft as an example. It took a while for Microsoft to understand where its revenue was coming from, and they finally figured it out. And that's why Azure, all they care about is driving nodes. They don't care whether you put a Linux box on it, whether you put Databricks, whether, they don't care what you put on it. They just want to drive nodes. They understand that's how they make their money. And I think it's sometimes taken vendors too long to get there. Oracle, quite frankly, still hasn't gotten there, and that's why their stuff is going somewhat stale. And now they can milk a lot out of their current customer base, so they'll have plenty of time that they can sit around and do their thing. But I don't think a lot of people are going to Oracle for a huge amount of innovation. And so, and I think what vendors did is they just kept saying, well, you need to buy that. I mean, Informatica is classic with that still today. I mean, Informatica, you want a new source, that's 50 grand, or you want this, or you want that. And the other piece of it is, or the biggest side of it was that people felt like vendors had their back with indemnification. Well, they came to find out that they really didn't. And so then you sit in a meeting and you start weighing your options, and things, if it's a well-backed project, you maybe start looking at that. Should you, there's plenty of ones that you shouldn't use. You should understand the risk that you're taking, which there are risks. But I think when it comes to development environment, and I don't know the specifics around the JS thing, maybe that was a development environment, but I mean, that's another thing that Microsoft was slow on too. I mean, they used to charge like an inordinate amount of money for Visual Studio. And it's like, well, wait a minute, they're producing things with your stuff that's in your best interest. So,
I mean, especially for something like that, where if you get someone really used to an IDE like Visual Studio, then they want to stick with Visual Studio. Now you're
absolutely
kind of
right.
And we've got
and they're slow. Now. And just one more thing on that, and they don't necessarily, like if you're doing .NET stuff, like probably your only choice is Visual Studio then. So why wouldn't you, anyway, go ahead.
You make it easy to get in, so it's harder to get out.
Right, exactly. I don't always understand it, but.
A question from chat. I recently had to reverse engineer Python code with little to no comments. I didn't know Python, but I got the gist of most of it. Do you teach students to comment Python to help with debugging?
Yes, I do. I do my best to do that. Absolutely. In fact, I get students mad at me sometimes because I continually ding them a few points because they're not commenting their code. So yes, I'm a strong proponent of commenting one's code. Now I will admit sometimes my classes get large and towards the end of the quarter I start dying and I might, let that go a little bit, but I do. It's definitely something that is at the top of my list. Yes. And yeah, it makes life a lot easier.
A great example, I think, is my current job. I do web development, and you comment your code, not just for your own readability, but because someone else might come by and have to change something later. And if you don't comment your code, that's just you being discourteous to your fellow workers. Right? You want to make sure they know how to do it.
Exactly. And in a larger environment, it's paramount, because I might work on this library and then I check it in, and the next time I might be doing something else. So you might be working on it the next time. And if you don't understand what I did, then that's not good. And I think people need to be open to, I think that we get kind of closed off to change a little bit. So, I like it when somebody says to me, well, I checked your code out, but you really kind of messed this up, and that's not really the best way to do it. That's fine. Okay, what is the best way to do it? Let's talk about that. And so, I go in knowing that I don't know everything, in fact, far from it. And I think, I think that number one is if it's approached right from the person that doesn't know. I think that we have higher expectations of ourselves than others people have of us. Nobody expects somebody to know everything. So, feel free to ask questions, that sort of thing, but also just be open to some criticism, which I think is hard. And I think it can be especially hard. I don't know how much people know about the US, but in the, I'm obviously right in the middle of the country in the Midwest. And in the Midwest, people tend to be, there's just a lot of agriculture atmosphere, which is very independent. And, I can, fix that engine or whatever. And I think, sometimes it's good to ask questions, which can be hard, sometimes in the area of the country I live in. I think people are more open to criticism sometimes on the coasts, quite honestly.
I've definitely also heard of issues in places where employment can be a little bit more precarious, where people might be more guarded on what they do to make themselves harder to replace. And not commenting is probably a way to do that, although it's a bad practice to get into.
Well, and it doesn't really, and as somebody who's a consultant, so I've sat with managers and gone down lists like that. I'll just give some free advice. It doesn't help you in those meetings either. It doesn't protect your job, because at the end of the day, and I don't mean to be harsh by saying this, but it's just a fact. None of us are indispensable. I'm not indispensable. Nobody is. And so, but I will also say that as a consultant, I think people sometimes perceive me as a threat a lot. And so it takes some work to say, no, I'm just here to help you. I do not want your job. I have no interest in your job whatsoever. And, but yeah, I think it somebody is actually makes them, it's sort of counterintuitive, but they make themselves more indispensable by sharing.
Absolutely.
Quite frankly.
I agree. Someone else asked if you have any favorite books or online learning to recommend for people who want to learn Python.
Oh, wow. Well, to be honest, one of the places that I go to that's really functional is, I think it's WS3 Schools. I think that's what it's called. And they have, I mean, it's great because you can go out there and run code right in the environment. So maybe I'm not supposed to say that, I don't know, but I like it. I can't think of any books off the top of my head. The textbook that we use at Southern New Hampshire University, which I really like because it has the labs right in it. It's not perfect. It has plenty of problems too, but overall it's really nice because it has nice labs in it. It has test beds already made and stuff like that. It's Zybooks, which is a textbook, I guess. If people are in the academic world, there's another school that I'm teaching at, and they are actually looking at that book because for students, it's supposedly actually the same price, and you get kind of all that digital functionality. It has a I won't say compiler, I'm sorry, interpreter right in it, that you can write code and then you submit that code for the lab. And it makes the grading go smoother for professors, which is nicer for students and all those sorts of things. So.
And before I pass it over to Eden to say thank you very much, I also want to give a shout out, as someone pointed out in the chat. There is a group that runs datathons in Ontario called Data for Good. And they're doing one in the Waterloo region, a Canada-wide virtual datathon spanning a week that starts this weekend. I tossed the link into the chat itself. I've taken part in the Data for Good thing. Have you heard of them, Frank?
I haven't, but it sounds like a wonderful thing, and I'd love to be a part of it. So put it in the chat and I'll take a look. I don't know what I have time this weekend, but
no worries.
I like anything that's out there. So cool.
One I took part in, they showed you up, they put you into teams, and they basically said, here's a data set and tell us some interesting things about it. And you just worked away at it for a couple of days.
we have some things, Mini Analytics, which is a play on Minneapolis, does some things like that here too. Yeah, they're fun. Cool.
Okay.
That's a great name. Yeah, and that is very cool. Thank you for sharing that, Nick. And thank you so much, Frank, for all of this. This has been a really interesting talk. I feel like it's sort of put a new spin on a lot of this for me,
cool,
which has been really interesting to see. And I hope everyone appreciated and enjoyed it. So yeah, thanks everyone for coming out, and thanks Frank for coming out and sharing with us.
Yeah, well, I love doing it, and love to do it again sometime on something.
Absolutely.
Always more than happy to. You guys are great folks. So